Cool. Hi, everyone. Everybody still awake? Was a long conference day. Good. Let's see where we can take this. I want to talk about logging patterns and how to hopefully improve your logging life, or also see like what pain points you're suffering and if you have like any problems that we can solve. So who is doing... Okay, you have your Java application. I'm just using Java as an example here, but it could be anything. So you have your console log, and then you probably run that somewhere in production, and then you want to see what is going on. And oftentimes you probably SSH into that machine, and then you do something like this, like cat the logs. Who is doing something like this? Okay, that is way too many. We will see what we can do about that. The slightly more advanced version of that instead of cat would be if you switch that over to tail. Who's using tail? Okay, yeah, everybody's using tail. There's one even better version than tailf, which is less, and there should be a less plus f then. Anybody knows what less plus f is doing? Yes? Yes, but what is the advantage of less over tail? Yes, exactly. You can break out of that and then you can scroll, or you can even search. Like if you do / and then type any string, you can search. So if you need to SSH, the less plus f or less is generally the best option that you have to do anything for your logs. But at some point, you probably figure out that this is fine or this is not so fine. So oftentimes you will kind of say like, okay, yeah, I have one server, this is all going well. And at some point you have more servers, and you might do something like this. So you have like 3 servers, and then you try to connect to all of them and see what is going on in your logs. And then you keep growing, and at some point you end up something like this. And you can see basically one line or something like that per server. And then it's no longer that fine. And then you're probably like this. And the point is kind of we want to avoid having this situation, like especially the lower half where everything is on fire and everything is terrible. We don't want that. We kind of want to avoid getting there. So the idea is to log all the things, but in a slightly more intelligent way than just SSH and tail or less. So why am I talking about that? I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. We're doing a lot of logging, so I always try to talk about what we try to do there or how you can improve your life. So I guess most of you are familiar with Elasticsearch, which is used for searching. And if you're searching on any of these sites, your search will go through Elasticsearch. However, at some point we figured out that logs are also kind of a search problem, because nobody is interested in storing their logs. Everybody is just interested in finding their logs or finding something useful in the logs. So that's when we realized that and branched out and said, oh, we could add some more products. So Kibana we have for visualizations, and Logstash then to get the logs and probably parse them and enrich them. And this is, or was, or is, or whatever you want to say, the infamous ELK stack. So you can see Elasticsearch, Logstash, Kibana, and well, one is sitting on top of the other, and that's how you get your logs. Who's using that for logging? Okay, good. So this is also widely used. So security logs, for example, if you're playing any games with Blizzard, and especially if they launch some big new game, they will have a lot of data in our engine to store and see what is going on. And then we added this one here. Anybody knows what that is? That is Beats. And why did we add Beats? Initially, we always had Logstash everywhere. And Logstash is nice, but it's based on... So initially it was Ruby, now it's JRuby, so you always need the JVM. If you're a Java developer, that's fine, because you have the JVM everywhere anyway. If you're a PHP, .NET, Ruby, whatever developer, people were not very keen to have the JVM or at least the JRE on their servers just for logging. So Beats is like a lightweight agent or shipper. It's written in Go, so you get native binaries, so that can take the logs and just forward them. It doesn't do any parsing, but it will just take your data and get it off your server as efficiently as possible. And that's the idea of Beats. And then the problem is we have the ELK, and then we have this B in addition there. And then we call that the Belk or the elk bee, and you can see this is basically what we came up with. So you can see it's a bee and it has the elk horns, and it's a very funny logo. However, we are always about scaling. The problem with that is even marketing, even our marketing is kind of about scaling, and they figured out, well, this doesn't scale, because what happens if we add another product? Then we'll probably have another letter, and we need to figure out another animal or make up another animal. And then we need to redo the entire branding, and it's kind of not very scalable, and it will get very hard. Whatever letter we add, probably it will be very hard to make up a proper animal out of that. While I do have some stickers with the elk bee or belk here, what we kind of settled for officially is just to call it the Elastic Stack, since this is much more scalable. Whatever open source products we have, we can just put that in there, and it's still called the Elastic Stack, and we don't need to redo the branding and naming. But Elasticsearch, Logstash, Kibana, and then Beats, these are the components that we have in that stack. And today, I want to use those to collect my logs and see how I can combine them. So we will always put the data in Elasticsearch to centralize it, and then Kibana to visualize it and see what is going on. How we get the data there will depend a bit. So either we can use Beats or Logstash or any combination of them. And we'll see various approaches of what we can do. And these are the patterns I want to cover. So all I'm showing today is open source Apache 2 license. You can just use it for free and go crazy. No strings attached. Just because people are sometimes asking, like, what is the license of that? Or what sometimes people are also asking is, like, what is the database behind Elasticsearch? What is the database behind Elasticsearch? There is none. So it's basically Apache Lucene, which is the library that is writing data to disk. But there is no other database or data store behind that. That's it. Okay, so I will build a very highly logged or monitored or whatever Hello World application. So this will be very simple, but you will get the idea from that. So I will use, like I said, I will use Java just as an example. So my logging bridge will be SLF4J. I use logback as my log appender, and I use structured log messages with MDC as well. What does MDC stand for? Yes, map diagnostic context. It's basically to have some structured information in your logs as well, and have like a generic format to do that. And we'll use that too. You could totally do the same thing. I know depending on in which circles you are, people sometimes make fun of PHP, for example, but also PHP has a proper log appender. So it really doesn't matter what language you're using. There is no excuse not to use a proper log appender. So that you can totally do. The one thing I want to kind of avoid is like, we're not going to use print to log out anything. I guess nobody's doing that. Nobody has to raise their hand. It's okay. The other thing I don't want to have is like very tight coupling between my logging system and my application. So if I would need to have some calls in my application, like every time I log something, I have some specific library to call that is bound to the logging solution I have. I would also try to avoid that because it will make changing my logging solution very hard afterwards. So I want to get that out of my application as much as possible. But with Logback, that won't be a problem because we'll basically configure everything and do everything through Logback. So we start with a few patterns. So the first one is kind of what people are probably most used to is to parse. So what we have is we have a classical log file. We have the file beat to collect the log file and forward it to Logstash. Logstash will then parse that, store it in Elasticsearch, and then we can query the entire data through Kibana. Pretty simple setup. That is pretty much the classic ELK setup. Just as I'm using for forwarding, I'm using file beat just because it's very lightweight. And especially if you have lots of servers, you probably don't want to have Logstash on all of them because it's a JVM process. It needs some memory. It needs some resources. Probably you want to keep it rather lightweight there. So I'm using a very simple logging application. So otherwise I always get lost. So no, this is not what I want. So not much is going on here. So I'm basically logging some things in a loop. What kind of pattern or thing does this look like? Which everybody is doing in interviews? Yes, exactly. It's kind of FizzBuzz as a log. That's the only thing that I did. And basically, I also gave the log levels the right names because I think you always should think of error like, this is something where I want to be woken up at night. Whereas if it's a warning, then it's something, okay, probably somebody should take a look at that tomorrow. If it's only an information, well, we'll probably collect it in production. Debug is maybe something we might collect in development or not. And at the very top, I have one trace just to keep track of some information we have there. You can see I'm also including some structured information. So you can see pretty much at the top we have that MDC put. I have like some session information. The session is some random number between 0 and 199 I'm setting just to have something like a user-like tracking. It's just some user doing something which you might want to find afterwards. And then I'm just keeping track of the loop. And these are the two MDC attributes that I'm having in here. And then I have something here. What could that be? Any guesses? That's an emoji, and IntelliJ is automatically replacing that emoji with that Unicode. You will see which emoji afterwards. Because luckily, if everything works, our entire stack should support emojis by now. That was one of the improvements I think we have done in 5 or 6, and it was a much celebrated feature, basically, that you can have emojis for everything nowadays. It's kind of like one of these essential things. So that is pretty much what we will run through. So if I run that once, how many log message will I get? And I'm logging on trace. How many log events should I get in the end? Yes. No? Maybe not 20? More. Yes, it's trace. So that's actually a good question. So what I'm doing here, let me head over. So this is logback, my log appender. Basically what I'm doing here is I'm collecting on multiple things here right now, so we can just try that out. So for now, let's stick to console. If I have my console configuration, and you see console is very simple. I have defined my pattern, and this trace here says like which log level we are using. So if I run that, how many entries will I get? 40, because I have trace for every, so I have 20 times I will run through that loop. I have one trace for everyone, and then I have one of the others for each one of them. And we will get exactly one error. We will have more warnings and infos. Let's quickly run that. So this is where I want to go. So let's just run that. Bless you. Nothing like unexpected happening here. We're starting our application. We're getting some log, and now we want to collect it. So I have that running in the background already. So I have, with Docker Compose, I have all my setups running here. So they are collecting stuff in the background already. So let's head over to Kibana. If you've never seen Kibana, this is Kibana. The one or the things that we'll be most interested in today is Discover, because Discover is basically the raw data that we have here. And then we could build some visualizations as well. So I have just ran my application, and let's say I want to have the last 15 minutes here. And you can see I have 2 messages here, which is kind of weird. And if I expand them, you can also see that something has gone very wrong here. Any guesses what could be the problem? Why am I only getting 2 messages here? It's unfortunately a time zone issue. Because, well, it's UTC and it doesn't assume that it's UTC. Just to show you what this is doing. So we should have something in the last 15 minutes. But let's say we want to look like up to 3 hours to the future. If I do that, you can see these are the 2 messages we have right now. And then actually the 14 messages we were interested in are exactly in 2 hours because, well, the UTC offset is sometimes not our friend. So the first thing we will need to do here is we will need to fix that. I have my logstash configuration here. Just what that looks like is... So basically, what we have is we're taking the data here from Beats. We just forwarded that. So Beats is basically taking the file and sending it to Logstash on that port. And then if it's coming from FileBeat, we'll basically parse it. We'll get into the parsing in a moment. We have extracted the time, the time or the timestamp here. The one thing that we haven't done was set the time zone properly. That's why everything was off. That is kind of one of the first things you will run into. And then we'll split everything up. And while I will run or restart my Docker container in the background to make that, did I save my change? Let's quickly make sure I did change that. And I want to basically restart my logstash container. No, that's not what I want. So basically, I've reconfigured that. I will restart logstash. You can see in the Docker Compose file, a lot of stuff is going on. In the meantime, while that is happening, we can take a look at parsing. So let's take one of these warn messages here. What we have added now is, because parsing is always a fun or not so fun exercise, we have a so-called grok debugger here. What grok debugger basically does is you can take a log statement here, you can define a pattern, and then you will see what happens. Because that, if you have the classical log file, that is what you need to do. And who likes writing regular expressions? Anybody? If yes, it's probably the Stockholm syndrome, where you're kind of just used to that and you cannot really avoid that. Here, this looks like a pretty classical log line that you have. And we'll try to parse that apart. So it starts with a square bracket. Oops, that's not here. But here I add this square bracket. And then you don't need to write the entire regular expression, but we have something like called grok. Grok is basically named regular expression patterns that you can simply reuse. So you don't need to write it down to the regular expression. You just need to know how the pattern is called. And the syntax for that is basically you have this here, and then you say, like, this is the pattern I want to use, and colon into the field where I want to put this. And this here is a timestamp with a date. And if I'm not mistaken, that field is called timestamp underscore ISO 8601, I think. And then we call this timestamp. And if that is correct, let's see. No, this is not. Wait, timestamp. Okay, let me quickly cheat. I'm very bad at remembering the right names for that. And that is, of course, the wrong bracket. Yeah, otherwise it was correct. Okay. So here, basically, we have split out, if you know, like, this is basically the name of the regular expression that we have stored. So basically, you can target this up here, and then we say, I want to put this into the field timestamp. And this is what you get out. And then you can say either regular space, or if you don't know how many spaces you will have, you can just say space. If you don't give it a name, like if you don't do colon and field, it will just throw that information away, but it will parse it out. So you have timestamp, and then I think the log level here, which we have, is, if I'm not mistaken, is called log level. Log level. And I want to put that into a field level. Let's see. Did I miss a... Oh, yeah, that is indeed true. Thank you. I did miss a closing bracket. If I could type it. And then it will actually work. So here, you can see how much fun it will be to write this entire thing out as a regular expression. So luckily, Logstash is already doing that for us. So let's head over to Discover. So we haven't properly, or we have that here. Let's see if our change has actually worked. So I want to run that again. And if my change with the time zone has applied, we should be able to switch that just to the last 15 minutes. And it might take a while. Or not so. It shouldn't take that long, hopefully. Come on. No, that's fine. That's exactly where I wanted to be now. Because my local time zone here is Vienna as well. My computer, my computer never changes time zone to actually not confuse myself too much. Otherwise, I would need to change it for every single demo as well. So my computer stays in Vienna or in Vienna time zone, and then I don't need to think about the specific time zone. So now everything worked well. more or less, because you can see we have 40 messages here. If I open one of them here, that's actually not the one I want. If I open one of them here, you can see this worked actually pretty well, because this was the original log message that we have. I have parsed out, for example, that session information, the MDC information, we have parsed it out. We have also, I have called it the message, investigate tomorrow. So we have parsed all the independent pieces out of that successfully. The only thing that is slightly weird is I have 40 entries here, and then I have 2 additional ones here. Any guesses what that could be? And let me add one more field. So one thing, this view is not showing you perfectly like what is really going on here. You can here say, for example, I want to add specific fields that I'm interested in. And there is a tag, and I want to add the tag. And if you add the tag, it will tell you, okay, here were the 40 messages that we have actually found correctly. And then we have 2 things where our parsing failed. Any guesses where the parsing could fail? Multi-line statements. Who likes parsing multi-line statements? Because what happens, if you switch over to this log here, you can see this here. This is a problem, because normally we have a single line which starts with a square bracket, and then you have the entire log message. And sometimes you have like, this is actually a very short stack trace. It could be much worse. But this is actually 3 lines. So you have, this one is the first line, which we were expecting. And then my logging system doesn't know what to do with that, basically. So it says, okay, this is one log message, this is another log message, and this is the third log message. Is this very helpful? No. Because like breaking this up into 3 independent stack traces is not going to help. So where do we need to change this? Can we fix this easily in Logstash? Not really. We would need to fix that in FileBit, which collects the files. And actually, that's exactly what we need to do. So for a change, this is the one that is collecting that here. So you can see we're collecting some log files. We're sending it somewhere. That is all good. What we need to re-enable here, what I have explicitly commented out, is we have this multi-line pattern here. That multi-line pattern basically tells FileBit what is one message and what is the next message. Normally it would expect that every single line is a new pattern. What we're doing here is we're saying every log element starts with a square bracket. That is like, you can see a regular expression like the little roof is like, okay, it starts with square bracket, which we need to escape. And then we say basically, if it doesn't start with that, that is kind of like the continuation of the previous log message. So if it's not that, negate true, match everything after that one that is not there, put that in together with the previous line. So this is exactly the pattern that we then need. And once again, we can actually run this. Oh no, sorry, that's not very helpful. The one thing that we need to do is we need to restart the FileBit because I've changed the configuration. FileBit will be very fast to actually start back up again. So we could watch it here. It will just start up again, and then it will be working for us. So once that has been done, I can simply run that. It will collect that, and now we should only collect 40 messages exactly. Hopefully FileBit has come up now and has already collected and forwarded. Since you saw I did that twice, and like the last 2 which parse or which fail, I always go to the next one. So this is actually the one that we want. Like this is exactly the 40 that we want. These parse failures are kind of like from the previous run, which I have done just before we have restarted FileBit. So now it's actually parsing everything correctly. And you can also use that information now, since everything is parsed out in a structured way, to actually visualize something. For example, let's say I want to use a vertical bar chart, and I want to use which is the most common log level that I have. So for example, we're here still using the parse index. So you can see over the last 15 minutes in total, we had 126 events. I want to split that up now. I want to see the log levels, for example. So I say, okay, this is a specific term I want to break this up on. And then we have a field called level. And let's say I want to have the top 15 log levels, though we don't have that many log levels, but just to be sure. And if you run that, you can see trace is by far the most common one. It has like half of the entries are trace ones. And error is the least common one, which has just occurred 3 times since we have run that many times. You could also break that down further. For example, if you say split, you could then say, I want to break that down into like this, for example, the session information, which we have added, just to see like how many users or how many errors were encountered by which user account. These are pretty much randomly generated, but by random chance, like this user has 54 traces and this one has just 11. So you can see which users were most affected by specific errors or more affected than others. And you could extract any meaningful information from that. For example, if you have like you could also easily filter that here. So if you say, I have my level, you can say, I'm only interested in the errors here. And then you only get the errors. And now we should, by the way, also find out which emoji we have been using. It's this one. And you could even search for that specific emoji then. But it's like we're emoji friendly here. So you could just say, if user experience is the swearing emoji, then just show me those if you have collected them. Okay, so this is pretty much the parsing, and that works well. It's just not ideal because, well, you need to write the regular expression. And maybe we could do something that is a bit better. So continuing here, the good thing is you don't need to change your application. You can just keep using your .log files and you don't need to touch anything else. The bad thing is, well, you could have stuff like timestamps break. You need to collect multi-line statements correctly. You need to write the regular expression for that. Maybe not that much fun. What you could do instead is you could send everything directly through your log appender. So if you have the right log appender, it can talk to logstash directly. And since your application has the information in the structured format, it can send it in the right structured format to Elasticsearch directly, and then you don't, or to logstash to hand it over to Elasticsearch. You don't need to do any parsing anymore. So what that would look like, this looks simpler. In your application, you basically have the specific log appender. It's kind of like what the leftmost symbol is trying to symbolize. Forwarding that to logstash directly, storing that in Elasticsearch, and then you can access that through FileBeat. And that has been working all the time. So you can see these were all the events that we have collected. Let's kick out that filter because otherwise we won't see the right thing. If I now switch my index from parse to send, you can see this has all been working kind of like in the background all along. So here, you can see everything that we had here, including the NDC information, is in my log event, and we have sent that directly. Who thinks this is a better approach? Who is doing something like that? Okay. So the one problem with that is, so if we have, let's quickly do something like this. For some reason, logstash. For some reason, sorry, stop, not down. Docker Compose down is not what I wanted here. For some reason, for example, logstash is down. What happens in your application if logstash is down then? It won't capture logs. So let's quickly run our application again. That's fine. Let's say I'm heading back to my parse events. And the parse events, once they have been parsed, obviously they are not being parsed because logstash is parsing and I have taken down logstash, right? So nothing will appear here either. If I restart logstash, no, where's my history? Okay. Docker compose.logstash. Well, it's a Java process. It will take a few seconds until it's up again. Will I get the logs from the structured log, from the parsed logs now? Yes. Will I get the logs from my sent logs? No. That is kind of the trade-off that you're doing here. While it's much less work, maybe the logs, when something in your network is not working as expected, are the most interesting ones, because everything works in the sunshine case, you're not that interested in the logs. But if something is down, maybe that's exactly when you want to see what your system is up to. So let's see here, Logstash is still starting up. It's starting, successfully started. By the way, why did FileBeat still forward that information to the parsing here? Let's see. Once it's really up and working. Come on, parse. Why is FileBeat, why can FileBeat still forward that? Because FileBeat just keeps a queue and knows what it has to send. Or actually, it's not a queue, it has a pointer to the file system, and it knows everything up until here I have forwarded to Logstash, and Logstash has acknowledged that. And if Logstash doesn't acknowledge something, it will just keep the pointer to the file and say, okay, I will try periodically, is Logstash coming back? And as soon as Logstash is back again, I will keep sending everything after that pointer which I haven't been able to send and gotten the acknowledgement back. Come on, demo. I hope. Okay, let's see. Yes, it took some time until it came back up, but you can see here it has basically backfilled that. By the way, if I have a log rotation in the meantime, will I still be able to get those logs if I had a log rotation? Yes, let's say at least on proper operating systems, I do. Like everywhere where I have an inode, it will work because it's basically not on the path, it's tied to the inode. So even if you rename the file because you have the log rotation, you cannot compress it because we cannot process compressed files right now. But if you just rotate it to a different name, the inode will stay the same. And then we will still collect that under the inode. So even if you rotate the file and we haven't been able to send it and acknowledge it, we will still send it afterwards. So you can see here we got our 40 log messages, whereas if I switch over to the send, you can see we're just missing the logs here. I mean, that's pretty much what you expect, but that's the trade-off you're doing here. So that is nice because you don't need any files anymore. The thing is, well, if something is out or down and you have this coupling here, if the system is not reachable, your logs are just gone and you don't have any option to see them. So probably also not that great. What could I do instead? One other option is I can write out structured log files. So basically what I'm doing is my log appender will write out JSON directly, since Elasticsearch is storing JSON. FileBeat can collect that JSON file, store it directly into Elasticsearch, and then I only need Kibana to visualize it. I don't need Logstash in that example anymore because I don't need any parsing. Sounds simpler? It sounds simpler. The one thing that is not that simple or looks slightly scary then, the one thing that is slightly scary then, if I head over to my logback file, you can see, okay, this was my console appender. This is my flat file appender. That was also easy. The Logstash forwarder is actually pretty much the most simple one. But the one for JSON that will actually write out the JSON file, so we could also look at the JSON file directly, but that's not that interesting, is that you need to configure some stuff explicitly. For example, here, I am saying, okay, this is UTC, so I won't screw up time zones again. And I say, these are all the fields that I want to explicitly keep. And I'm also including my MDC information here. Basically, what you will get is, let's quickly say less logs. The JSON log is what I want. This is what I'm writing out in a structured format. So you can see I have everything, like I have my app timestamp field, I have my severity, I have my session. If we scroll around, we somewhere will find a stack trace. This is this one here, for example. So you can see \n, \t. This is what the stack trace will look like. So, and well, emojis are unreadable again, but it will be readable in Kibana. This is what we're writing out, and then logs, FileBeat can just forward that, and that's then very simple for that. By the way, the FileBeat configuration for that one is very simple. Basically, we say we have a JSON file, we have some fields that we want to store, we have some configurations that we do, but not really that much. And that's all I really need here. And I'm telling it, I want to store that under the index structure. So let's see if that worked. If I head over to structure, hopefully, since some, okay, let's run the application again, just to make sure it still works and we haven't broken anything. And FileBeat should then collect that. And you can see, well, we have collected our 40 elements here, and that still works. So that is pretty simple and should do the trick. And that is generally the approach we would recommend for you. Or if you have a legacy application and you have a .log, keep using that because probably nobody wants to touch it. But if you're writing a new application, generally we would recommend writing a structured log because you don't need parsing. And it will still work if your network is down because you have the file and you can always fall back to that file and collect it as soon as everything is up in your network again. So the right format, you don't need to do any parsing. You might have some JSON serialization overhead though, and you need the bit of logback or log appender configuration. Not that much. Once you have it, you can reuse it everywhere, but well, there is a slight cost to pay for that. Okay. What changes if I containerize my application? Or what are my options if I containerize something? So when I say containerize, I guess everybody uses Docker. Anybody using not Docker? One half person, okay. That's pretty much what we see. So we'll stick to Docker. By the way, I think this is the proper Docker logo, by the way. So Docker solves that problem. It works on my machine. And now you can, by the way, say it works on my container. Because probably, at least I had this coworker at some point in the past who always said like, oh, it's working on my machine, but it never worked anywhere else. And Docker is supposedly solving that, maybe. Because at some point, whenever you have somebody who says that like, oh, it only works on my machine, you need to basically tell them, okay, back up your email because your laptop is going to production now. This is the only thing where this is working. Okay, so where do you put FileBeat? Generally, you can put it on the host and collect it from there, but sidecars are what we would recommend. We have the official Docker images for all the beats, and I have been using those to collect everything. So you basically have the sidecar, and what you then need to do is you need to access the JSON logs, which are the default. Basically, this is all you need to do to get that information out of the JSON, out of the Docker default JSON logs. And one of the nice things that we have down here is that add Docker metadata, which looks pretty simple, but it does stuff like this, where it will actually enrich all your events with something like this. So you know which is the container ID, which is the name of it, what is the image name, and probably what labels have you applied. And that will make it much easier to actually filter down to a specific Docker image that is making trouble, or to a specific application in all your container logs. The alternative to that is if you have your application and you mount out the directory to log there, that's pretty similar to what you have been doing in the past then. And then you could mount that directory where your application, so this here is your Java application, writing its logs to this on the host, basically. So this is inside the container, but this is mounted to outside of the container. And then you mount that logs my Java. The logs my Java, you also mount that into the FileBeat sidecar, and you can collect the information here. The main downside of this one is you don't have any Docker metadata, because you kind of lose the connection to the Docker ID, and you cannot resolve the Docker ID. Because basically what we did did here is, since we have the Docker ID here, basically, we would use that information from the folder name to look up any metadata from the Docker socket or the Docker daemon and query that. If you mount the directories kind of like explicitly and you lose the Docker ID, you will lose the metadata around the containers. That is a trade-off you need to make. Something that would or makes sense, which I didn't do yet in my examples here, is you can also mount the registry file of FileBeat outside of the container. Why? Anybody knows why that makes sense? I've spoken about this registry file, which basically keeps the pointer to the log file and says, I have sent everything up to this point. If you keep that file inside the container and at some point you have a version update where you replace it, basically everything that matches your collection pattern will be recollected, because there is the registry file is missing, where FileBeat keeps track what it has already sent or forwarded and what it hasn't forwarded yet. But if you mount that to a directory outside of that, you can simply replace the sidecar container for FileBeat, and you won't recollect the data unnecessarily. So that is kind of an optimization for, or something that if you frequently replace containers, which you might want to do to keep that registry file. And sometimes you have fun stuff like this in your logs, which is fun, but pretty much crap, because you don't want to collect that. Nobody wants to store that in a central fashion and then be able to parse that. What you can do now is, there's actually a pretty recent feature. I think we added that in 6.2, which is the latest version, is we have some auto-discovery feature. And basically what we're saying is, if something is a Docker container, you can do some conditions, and if they're met, this config will be applied. So my condition is here, if the container image has Redis in its name, then I basically want to drop that stupid ASCII out. So what we're doing here is, we have this if condition. If it's based on a Redis container, then I assume, well, this is the container ID. Take that container ID and basically throw out everything while you collect the logs from that container. And you don't need to explicitly say, okay, this specific container is a Redis container, but you can just do it through the name, or you could also do it through tags, where you have specific rules for the log collection, going through the meta information of your Docker images. So it's kind of the hot stuff, but it adds some complexity, and you have some new problems that you didn't have before. What if you want to orchestrate? And I guess when we say orchestrate, pretty much everybody is on Kubernetes, right? Yeah. Nobody dares to say anything else or disagree. So oftentimes it's Kubernetes. Where to put FileBeat? There's this concept of a daemon set, which basically makes sure on every single host that you have where your Kubernetes pods are running, there will be one instance of, or as many instances as you define, but for FileBeat, you would define one instance of FileBeat runs on every host to collect all the log files from that host. And then you can also enrich that with the metadata. So if your FileBeat container is running as part of your Kubernetes cluster, it automatically has access to the Kubernetes API and can then enrich all events with Kubernetes information. So you will know stuff like the pod or namespaces. If your FileBeat is, for example, running on the host directly and it's not part of Kubernetes, instead of saying in cluster, you would need to explicitly say, where can I access Kubernetes or the Kubernetes API to enrich the information? If you have set that up correctly, you would have something like this, where you can see, okay, you have some container information that we had before, but you also have stuff like the node or the namespace and the pod. And then you could filter down on that afterwards and see like, oh, I'm only interested in one specific namespace or in one specific pod, for example, because something is going wrong there. You can also drop the ASCII art again, which... well, the Kubernetes namespace is just the same thing. Whatever makes sense here, maybe the Kubernetes namespace should be Redis or whatever. And then you can drop the ASCII art again. One other thing that can be very helpful is you probably, if you have a large cluster, you don't want to put all your logs in the same index. You might want to split it up into multiple indexes based on namespace, for example. You can use that Kubernetes metadata actually in the index variable. So instead... I have kept it very simple here. Here, my name was always structure send parse. Normally, what would happen behind the scenes, you have like a daily index or a weekly index, so you can just throw out the data after some time. But you don't want maybe you don't want to collect all the logs from all the pods and namespaces into the same index, but you want to break that out into different indexes. And then you can add that meta information here, where you basically say Kubernetes namespace, so that is the variable Kubernetes namespace, FileBeat, and then I concatenate that with the FileBeat version, because otherwise we might have versioning problems, and then you have a daily index pattern. And that way you could split up, even if you have like a huge cluster, you can split up your logs into more logical units and make them accessible to the right people working on the application. So that will making that structuring a lot easier. It's even hotter, but it also has more complexity in the end. Totally do that if you know it. What we often see is that people don't know our stack and don't know Docker or Kubernetes, and then thinking combining two complex systems will make it much more awesome. But that's normally not the case. We've seen like a lot of despair and tears basically just two complex systems colliding, and then nothing works anymore. So to wrap up, and yeah, we're pretty doing well time-wise. If you want to get the code, it's on my GitHub account, java-logging, because I might do the same thing for other programming languages at some point, maybe. So what have we done? We have done parsing. You have a classical log file. You parse it with a regular expression. We've seen some downsides there. You can send it directly, which is nice because you don't need to parse. You have just an additional log appender. With the downside, if your system is down, you won't see anything or you won't get anything. Structured logging, if you have a JSON log appender, is what we would generally recommend if you can. And then we have seen more metadata and orchestration around containers and Kubernetes to just enrich your events, but nothing fundamentally changes. As long as you have structured events, you can just use the same things as before. If you don't have structured events, you will probably need to create structured events with a regular expression first. Or you can send directly, but we've seen downside if your network is down, stuff is down. And with that, we're pretty much finished. I have a bunch of stickers up here, so if you want to have stickers afterwards, tell me. I'm normally taking a picture with you. Let's see if it's too dark or not. Because I need to prove to my colleagues that I've been working today. Because nobody really knows where I am normally. Let's see. Yes, exactly. Cover your face if you don't want to be in the picture. And I've had my head in front of some of you anyway. Any questions? Just a quick show of hands. Who is using parsing in their project? Or no, let's start differently. Who is using SSH and tail or something like that? Okay. Who is parsing to centralize? Who is sending directly with something like Logstash or something like that? Who is writing structured log events? Okay. Any strong disagreements with what I've shown? Okay. Any other questions?
Hello there.
Hi.
I had a question concerning leaking file handles during logging operations. I have seen such things. I know that they exist. How do you deal with these cases?
You mean that if you have like you're watching a lot of log files and...
in essence, for example, we have a process A which writes its log file. After a while, it switches this log file to a new file, but keeps the old file handler open, and while the new information is going to the new file.
Right. So as long as it's within the pattern, we will still keep monitoring the file. There will be a timeout how often we try to fetch the information from that. Normally, we would rely on kind of like the file name pattern to switch to the correct file. And otherwise, it would be a bug if we keep monitoring the wrong file then. There might have been some, but I'm not aware of anything. I haven't seen any major complaints about that. Generally, FileBeat is much better in that regard than Logstash. Logstash had more bugs around that. By the way, what we've seen every now and then, what people try to do is they mount a remote directory and try to collect stuff from there. That is a really bad idea if you put it on NFS or something like that. Again, if your network is down, everything will be screwed up. And also, there are a lot of subtle file system bugs around NFS and how you handle them. Otherwise, I would need to check the issue tracker, but I'm not aware of, or I haven't had any complaints recently about that.
Okay, thanks.
Sure. Any other questions? Yes, back there.
In your examples, you did most of the parsing in FileBeat, correct?
No, FileBeat doesn't do any parsing.
Okay.
So I have slightly simplified that to avoid confusion. So there are two places where you can parse or use grok patterns right now. The first one is Logstash. We also have something in Elasticsearch which can also apply grok patterns.
Okay.
But FileBeat doesn't do any parsing. FileBeat is like an agent or shipper. It's just taking the file and forwarding it.
My question is that based on your experience, what is the load that Logstash, one instance, is able to receive properly and parse?
So that will very much depend on like how. how complex are the rules. And, like writing bad regular expressions is actually pretty easy. So we have seen people kill Logstash instances just by writing a very bad regular expression. Otherwise, of course, it depends on the box size, but I think you can parse like 5,000 events per second easily. By the way, one other cool thing, since you're asking about that, we have the monitoring now for Logstash pipelines. So you can see these are all the events I have running here. You can then switch into the pipelines. And this will basically also help you to debug how fast it is or where you're spending your time. So you can see right now I haven't sent any events. Let's quickly send some events to see something here. Then you will get another little spike of to see what is going on. And here you also have a graphical view both of the inputs. And then you can see like where this is being processed, and you can see how many messages are you processing here per, so the number of events. You can see the delay, and you can also see the time that we are spending here. And this will be very helpful if you have like a bad regular expression. So generally, I would start building something, and it will also always depend on like how long and complex are your log messages? How complex are your regular expressions? How many events do you have? What hardware do you have? But I would just start throwing stuff at it and then start debugging here to see like where am I spending my time? How much am I getting through? And where is probably something that I could improve? We also have multiple pipelines by now. That was another problem in the past, that sometimes you had something that should be fast and sometimes that could be slower. And now you can have multiple pipelines which will be processed in parallel. Because not all the data needs to be more or less real time. Something can take a bit more delays. So you could have like a fast lane and a slow lane for log processing. Things like that should take away most of the pain. But like the actual number of, okay, this is the number of how many events this will do, is very hard to tell. I hope that answers the question. No more time. Okay. If you have any other questions, just come to me afterwards and take some stickers. Thanks.